This video covers two of the boilers in the SOLARFOCUS range, the PelletTop 70 and the PelletTop 49, both of which have exactly the same physical dimensions. The 49 kilowatt version is merely limited using the software parameters. The other boiler that this video is relevant to is the PelletTop 35, which also has as standard the ash extraction system, which you can see at the side of the boiler here. So, to make you feel more at home with your new boiler, it's best that we take a tour and have a look at all the major parts. So, let's start with the front door. It's a one-piece front door which includes the touchscreen display, the Eco Manager controls for the boiler. These controls can also control the heating circuits, hot water cylinders, additional buffer stores, etc. But sometimes they're limited to just the boiler itself. It's possible to go around the boiler and around the heating system using these controls, and you can do output tests, etc. I'm not going to go into all the details now because we have a separate video to describe that. So, if we open up the door, have a look inside the boiler. A couple of things to note. This is the boiler data plate. This gives you the important information about the boiler, such as its serial number and power output. This black knob here, when I twist it, turn it in fact, comes off in my hand, and we have a green button underneath. This green button is so you can reset the boiler if it has an over temperature situation. If the boiler, for example, if there's a power cut while the boiler's in operation, it's possible that the boiler could get too hot, and then the thermal cutout will operate, and when the power comes back on again, you'll need to reset it. So you do that by pushing a small object into that hole there, such as a biro or a matchstick, something like that. Behind this panel here is the boiler power module. This is where all the connections are made to the various motors and igniters, other electrical parts of the boiler. All the sensors are connected here, and additionally the heating circuit pumps, mixers, other parts of the heating system. Behind this panel here we can see some of the important working parts of the boiler. We can see the three primary air magnets, which are all wired via this rectifier to the board. We can see the boiler feeder motor here, which rotates in that direction and is bolted by way of three Allen key headed bolts to the feed, to the cell wheel here. This is the internal hopper for the boiler, which is the reservoir of fuel used while the boiler is in operation. Here is the igniter. This is a hot air blower which blows air in at over 400 degrees onto the grate to ignite the fuel. And finally, we can see the door, which you can open to gain access to the grate. So the combustion occurs inside this compartment on top of this grate here. Here is the pellet spreader, which ensures a good spread of fuel across the grate. Finally, this lower door here gains us access to the ash chamber, where all the ash is gathered from the boiler. It has a little peephole so that you can look at the flames licking down from the grate towards the back of the boiler. You can do that while the boiler's in full swing, but you must never ever open the door when the boiler's in action. So make sure that that stays firmly shut while the boiler's in operation. Open here to gain access, when you're finished inside the ash chamber, make sure the door's shut properly and this airtight seal is made around the door. That's very important. Okay, the next thing for us to take a look at is actually under the lids, the two lids. There's a front red lid here, and now we're underneath the lid. We can see, first of all, the vacuum turbine is the most prominent object under there, with its two carbon brushes either side. This is what sucks the fuel into the day hopper or the internal hopper from the main store. We can see here we've got an inspection hatch for the day hopper with 8 bolts holding it down. This fin here is where the fuel enters the boiler. So the fuel enters the boiler here, fills up the day hopper. Once it gets to a level in this fin above this proximity sensor, then an LED, a yellow LED comes on here. The sensor's sending the signal then to say to the boiler, my day hopper is full. The other hose connection onto the top of the boiler is the return air back to the store. So essentially this turbine creates a negative pressure inside the store, which sucks the pellets in through the finned connection and sends the air back down this pipe here. I'm going to take the second lid off. We can see now the array of 5 motors, 1, 2, 3, 4, 5. These are all connected via gearboxes to the heat exchange turbulators. Now the turbulators are strips of metal which have flaps coming off either side, which act to turbulate the combustion gases as they pass through the boiler. By turbulating the gases, they ensure nearly all of the heat is transferred to the water jacket of the boiler. The secondary purpose of these turbulators is to clean those tubes, and it's by the action of these motors that they rotate and scrape the inside faces of the tubes clean, thereby ensuring high combustion efficiencies and heat transfers between services. Underneath the cable tray that runs along the right hand side of the boiler, you'll find the boiler temperature sensor and this thermostat here, which is the over temperature thermostat. The only other thing that we find at the back of the boiler that's important to know about is the lambda sensor, which is here, connected via this cable. This sensor is what detects the amount of residual oxygen in the flue and allows the boiler to get the correct fuel to air ratio at all times and therefore ensure complete combustion and high burning efficiencies. So here we are around the back of the boiler now. There are a few important components to know about here. This one's perhaps the most important. It's the induced draft fan. The purpose of this fan is to draw the combustion air into the boiler, and in fact it's sized such that it leaves the air standing still at the flue exit at the back of the boiler. That's why it's very important that the flue connected to the boiler has enough natural draft to take the products of combustion away. So the fluing with these boilers is very important and should be at a minimum 4.5 meters long and completely straight where at all possible. The flue also needs to have a cleaning access so that the flue can be swept. We recommend twice a year, but please consult your chimney sweep to find out how often he believes it needs to be cleaned. The other important device to know about at the back of the boiler is this valve here. This is a thermostatically operated valve, the sensor for which is screwed into the back of the boiler here. Should the boiler ever hit 95 degrees, this valve operates and cold water comes in here. It whizzes around a coil inside the boiler and it comes out into this tun dish here, absolutely piping hot. The purpose of this device is to prevent the boiler from being damaged in the event of a power cut or another cause of an over temperature event. So here we have the flue gas temperature sensor, which tells the boiler the temperature of the flue gases as they leave on their way up the chimney. The last component at the back of the boiler, worthy of note, is the boiler drain cock, which is at the bottom left hand side of the boiler, right down by the floor. This flue component here is a draft stabiliser, and it operates in high winds to open and draw air in through this T so as to keep the draft stable at the back of the boiler. It's a very important part of the flue. It mustn't be forgotten during the installation.